So this is another video on solving trig equations, but I realized that I didn't have any good examples of solving trig equations where you had to use a calculator to do the arc sine instead of using your knowledge of the unit circle to solve an equation. So I want to do two examples next to each other. So for example, if you had 2 sine x plus 1 equals 0, you got plenty of examples like this, so I'm going to run through it real quick. You would subtract 1 from both sides and you get 2 sine x is equal to negative 1. And then you divide both sides by 2 and you get sine x is equal to negative 1/2. And then at this point, the object is, or you'd want to take arc sine of both sides because that's how you undo sine. So if I was to write it out explicitly, this is what it would look like. Whoops. Arc sine of sine and arc sine of negative 1/2. Of course, arc sine of sine x is just x, and then arc sine of negative 1/2, you could throw that in the calculator, but that would give you a non-exact answer. So we are actually going to use our knowledge unit circle to solve this. So I'm asking when is, basically this is saying when is sine equal to negative 1/2. So if I draw a quick unit circle, sine would be equal to negative 1/2 there and there. Now if I would have done the calculator and took arc sine negative 1/2, it would have given me this answer here. It would have given me negative 30 degrees or negative pi over 6. But I don't need the calculator because I know that these are the two spots that are what I want. Now, in this case, let's say that we're looking for all answers between 0 and 2 pi. So notice in that case, the answer of negative pi over 6 that the calculator gives you wouldn't work because it's not between 0 and 2 pi. But we know that because our knowledge of the unit circle, that these two spots have a lot of different names. In other words, I could go negative pi over 6 to get here, or I could go 11 pi over 6 to get here. Or for that matter, I could go all the way around and then all the way around again to there, which would be 23 pi over 6. So there's a lot of different ways I can get to this terminal location, a lot of coterminal angles that in there. So again, in this case, I'm just using my knowledge of the unit circle because these are friendly angles. And I know that that one would be 11 pi over 6. And of course, this one over here would be 7 pi over 6. And that would be my answer if I'm looking between these guys. Now, if they would have said all answers, okay, so we're saying that we're doing a different problem now. Let's say that they, instead of saying only the answers between 0 and 2 pi, they asked for all answers. So at this point, you could use negative pi over 6, because that is a perfectly good answer. And then you could use 7 pi over 6, or if you wanted to, you could do negative 5 pi over 6. And then you just put a little plus 2 pi in here. 2 pi in, where n is all integers. So in this way, I'm listing all the answers. I'm saying start at negative pi over 6 and then add as many or subtract as many 2 pi's as you want to. And every time you add a 2 pi, you'll get another answer that works. Okay, so that's if it's a friendly angle answer. Now this one here, notice when we subtract 2 from both sides, we get 3 sine x is equal to negative 2. Divide by 3, we get sine x is equal to negative 2/3. And then we need to take the arc sine of both sides. So we would take arc sine of sine x. In other words, I'm undoing the sine, which means I have to take arc sine of negative 2/3. Of course, that just leaves with x over here. Now, arc sine of negative 2/3, that is not a friendly angle answer. I can't get negative 2/3 off of any of the friendly angles. So I grab my calculator and I take second sine of, let's make sure we're in radian mode first. I wasn't. Phew, that was a close one. Okay, so second sine of negative 2 divided by 3. And I get x is equal to negative 0.7297. Okay, that's like the negative pi over 6 that I would have got over here on this one. Okay, so that's the answer the calculator gives me. Now I know there's other answers like that, and if I'm looking between 0 and 2 pi, that's not even one of the answers I want, because that's not between 0 and 2 pi. So once again, I'm going to draw a little unit circle just like I did before, and I'm going to roughly draw where that is. Negative 7.2, that's right there-ish. And since I'm dealing with sine, I know there's another answer that's just like it over here, because sine is the associated with the y, or the opposite side of the triangle, the y coordinate or the opposite side of the triangle. And we know that's where sine is negative, in the fourth and third quadrant. We would not find this answer up in the second and first quadrant because sine is not negative up there. Although there are two angles here that have the same reference angle as that. But they would give us a positive 2/3 instead of a negative 2/3. Okay, so we need to name these two angles here, because those are the ones we're looking for, but they have to be between 0 and 2 pi. This is not between 0 and 2 pi. So the one thing I know is that this angle right here is 0.7297 radians. That's how big it is. So one of my answers is going to be 2 pi minus 0.7297. Because again, the idea is I go all the way around to 2 pi, and then I come back 0.7297 to get to here. And that would be between 0 and 2 pi, like we're looking for. Then I have to do a similar thing for this one. So how can I describe that? Once again, I know since the reference angle of this is 0.7297, I know that that right there is 0.7297 also. So a way to describe this would be to say pi plus 0.7297. And that would be my two answers. If I was, once again, looking for all answers, so this is a different question now, all answers instead of just the ones between 0 and 2 pi, then I would do something similar to this, except for I would just say, okay, I'm going to, in this case, negative 0.7297 would work perfectly fine, because I don't have to be between 0 and 2 pi. And I would say plus 2 pi n, where n is all integers. And then my other answer would have to be somehow, I'd have to grab this one somehow. So I have it right there. I could just use that. So then I would say pi plus 0.7297 and plus 2 pi n, where n is all integers. All right. So that's a quick little rundown of just one more teaching video on solving trig equations.